Question number 2 says that Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminium sheet. The diameter of the model is 3 centimeters and its length is 12 centimeters. If each cone has got a height of 2 centimeters, we have to find the volume of the air contained in the model that Rachel made. We have to assume that the outer and inner dimensions of the model to be nearly the same. So again, as we do in all the questions of surface areas and volumes, we'll first visualize the model, and this is how the model will look like. So we do have a cylinder at the center, and at its two ends we have attached two cones. The total length of the model is 12 centimeters and the height of each of the cone is 2 centimeters each. So to get the height of the cylinder, which is marked as H1, we will subtract 2 plus 2 from 12, that is, we have to subtract 4 from 12, and that gives us H1, which is the height of the cylinder, to be equal to 8 centimeters. Now, the diameter, which is this, is same for both the cylinder and the cone. The diameter is equal to 3 centimeters as given in the question. So the radius will be equal to half of it. So 3 by 2 gives us 1.5 centimeters. We have taken H1 as the height of the cylinder, and we can take H2 as the height of each of the cone, which is already given as 2 centimeters. Now to find the volume of the model, we know that the volume will be equal to the sum of the volumes of the two cones. So we write it as 2 times the volume of cone plus the volume of the cylinder. So now we will be substituting the formulas for each of these. The formula to find the volume of a cone is 1 by 3 pi r square h. So here we will be writing it as 2 times 1 by 3 pi r square h2, as h2 is the notation that we have used for the height of the cone. R we have not written 1 or 2 because R is same for both the cylinder and the cone. Plus the volume of cylinder is written as pi r square h1. Now we can take pi r square common and we are left with 2 by 3 h2 plus h1. Now let's substitute the values. 22 by 7 times 1.5 times 1.5 times 2 by 3, h2 is 2 plus h1 is 8. Now that gives us 22 by 7, 1.5 times 1.5 gives us 2.25 times 2 by 3 times 2 gives us 4 by 3. 4 by 3 plus 8 will give us, by taking the LCM, answer as 28 by 3. Now 7 ones are 7, 7 fours are 28, 3 ones are 3, and then 3 times 0.75 will give us 2.25. So on further calculation, we get the volume of the model to be equal to 66 centimeter cube. As all the dimensions were in centimeter, the final volume of the model will be equal to 66 centimeter cube.
To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.